Assigning absolute configuration to enantiomers, the RNS configuration of enantiomers. What we're looking at is putting an absolute configuration on a chiral center and assigning it an R or an S value, which stands for rectus and sinister. Rectus means right or clockwise, and sinister means anti-clockwise. So what we take is we take our enantiomer, we have an enantiomer here with the chiral center labeled with a star, and we have to assign a priority to each of these groups. Now you can see the lowest priority group here is a hydrogen. Priorities depend upon the atomic number of the atom that's attached to the chiral center. So hydrogen's got atomic number 1, so it's the lowest priority. So we mentally rotate this molecule so the hydrogen is hidden by the carbon, and we get diagram 2. And then what we'll see is we have 3 groups which we can effectively arrange in a circle. Now the highest priority group here is the amine group, because nitrogen's got an atomic number of 7. This is followed by the carbon of the carboxylate group, because carbon is followed by 2 oxygens. So carbon is effectively attached by a double bond to one oxygen, which counts twice, and a single bond to another oxygen, whereas the other carbon is only attached to hydrogens. So the priority moves from NH2 to COOH to CH3. That gives us a clockwise rotation, and so this would be designated rectus for clockwise. Priorities are assigned according to the Carnegie-Prelog priority system, where we just use the atomic number. So CH3 is a carbon which has an atomic number of 6 and attached to 3 hydrogens, which would be 1, 1, 1. The CH2Cl group is 6 attached to a atomic number 17 and 2 1s. So the CH2Cl group has a higher priority than the CH3 group. If we have double bonds involved, then we can count the atomic number twice. So an aldehyde group, CHO, is effectively C, which is 6, attached to O twice, which is 8, 8. So the priorities of the aldehyde group are 6, 8, 8, 1. The carboxylate group are 6, 8, 8, 8, 1. So carboxylate group takes priority over the CHO group. Here, if we have a look at 2 examples, the first example, you can see, we look at the priorities, you can see that hydrogen is the lowest priority, and so we mentally rotate so that we're looking down towards the carbon with the hydrogen behind it. And we find that we have on the top an ethyl group, to the right OH group, and to the left a CH3 group. So the priorities, well, the OH group takes the highest priority because that's 8. The ethyl group is 6 with the 6 attached, whereas the methyl group is a 6 attached to a 1. So the priorities move in an anti-clockwise direction, so this would be S for sinister. You can see the picture we have here, and we rotate them round, priorities anti-clockwise, S for sinister. The same thing we do here. This time, if we have a look at these, we've got the priority. The lowest priority, the highest priority is the ester group. Ester? It's not an ester group, sorry. It's the COCH3 group, the acyl group, effectively. That takes the highest priority because it's carbonyls, 6, 8, 8. Then we have the carbon attached to an oxygen, 6, 8. And then we have the methyl group. So once again, this is anti-clockwise or sinister.